Okay, hello. So we are back for part 2 from the video. So previously in part 1 we took a look at law 1 and law 2, which are our same base law, because as long as you got the same base, you times, your power will sum up, you divide, your power will minus. Okay, law 3, we're going to start with law 3, and law 4 and law 5 will be their own. So I'm going to do law 3 first. So what is law 3 over here? You can see at the third line. So we have a raised to the power of m and raised to the power of n on the outside, and the overall effect would be a to the power of m times n. Okay, so one more time, so a to the power of m, the whole thing raised to power of n, so the overall effect would be m times n as the index. Okay, a bit weird, huh? But let us take a look why. Okay, so same thing, we will flip to our textbook, we will turn to page 56 over here. 56. There is an investigation at the top part to discover the law 3 of indices. Okay, so first one over there, all the way up there, we have 2 to the power of 5 square. Okay, so means that we will take 2 to the power of 5, we will square it. So means 2 to the power of 5 times 2 to the power of 5, as you can see at the first line. So what does this mean is, if you want to use law 1, because we have the same base, so 5 plus 5 will give you 10. Okay, so actually this one is actually 2 to the power of 10. You can, add them together, 2 to the power of 10. But you can also take notice that, power 10 is actually same as power 5 times 2. Okay, so actually what is going on is you take the 5, you times 2 to get your power 10. Okay, so this is the first observation. Okay, second one, -9 power 4, and the whole thing you cube it. So what happens is that you got 9 power 4 times -9 power 4 times -9 power 4, 3 times. So and because they have the same base, we can use our law 1 of indices. We have -9 as a base, then we got 4 plus 4 plus 4, and there are 3 of them, so it will be 4 times 3. Okay, so overall you will actually see -9 to the power of 12 when you multiply the 4 and 3 together. Okay, so this one will need understanding from our law 1 of indices. So it's actually a repeated multiplication on its own. Okay, and because you repeatedly multiply on your own, right, you can just add up all the powers, so it's just a multiple of 4 and 3 over there. Okay, so let us look at the general law. Now a to the power of m raised to the power of n, so we have a power m times a to the power of m, and and a to the power of m, and we have n times over there. Okay, so over here we have n times of the m, so it is just m times n, just like that. Okay, alright, so without further ado, we go on to our practice now. Okay, and let us see, and let us try to evaluate, simplify all this nicely, and to leave our answer in index notation. Okay, so let us take a look at first one. So 6 to the power of 3 raised to the power of 4. So this one, by the law number 3, we can multiply their power together. So 3 times 4 will be 6 to the power of 12. Okay, B, k to the power of 5 raised to the power of 9. So we have the base k over there. Alright, so when you have a power and raise another power outside, we can multiply them. So 5 times 9, 45. Okay, k power 45. C, we've got -4 power p and power 3, and we have -4 power 5 power p. So what we can do is, -4 will be the base, power p power 3, we have 3 times p, so 3p. Okay, and we can multiply by -4 to the power of 5 to the power of p, so we have 5p like that. Okay, so we have 3p. Okay, the same base now, we got same base, right? So the same base is -4, and the addition will be 3p plus 5p. So altogether it will be -4 to the power of 8p. Sorry, my pen very thick. Yeah, power 8p. Okay. Alright. Okay, alright, next let's take a look at question D. Alright, for question D over here, we have 3q to the power of 6, 3 power 4, and to the power of q, 3 to the power of 3 to the power of q. So how do we simplify this thing over here? So we will continue with our multiplication one. So like 6 and q will be together, so 6q, right? Multiplied by 3 to the power of 4q. Okay, over 3 to the power of 3q. Alright, so over here, then we can go ahead and do our law of indices. So we have a 6q plus 4q minus 3q because we are dividing, right? At the bottom is divide, so minus 3q. So the final answer would be 6 plus 4, 10, 10 minus 3 will be 7q. 3 to the power of 7q. Final answer. Alright. Let's take a look at number 2. Now given that this and that, find the value of n. So now this one is a bit special. Question 1 we will need to simplify, and sometimes we need to evaluate. For part 2, what we need to do is we need to solve for the value of n. So solving, right, there is a very different thing going on, and let me show you how is it being done. Okay, so let's take a look at this equation over here. We have x to the power of 8 times x power of 3 raised power n divided by x power n power 2 and equals to x power 10. So over here we have, okay, I'm not going to write times and divide because it's all, okay, for this, okay, I will write times and divide and I'll try to follow this, okay, and we'll see how it goes. Okay, so we have x to the power of 8, okay, times, we have x to the power of 3 power n, so we have 3 and n, x to the power of 3 raised to the power of n, so x to the power of 3n, divided by x to the power of 2n, like what we've seen earlier, then equals to x power 10. So what we did is we've simplified the object, the powers first. Okay, next, on the right hand side we cannot do anything, but on the left we definitely can simplify. So on the left, right, we have, let us combine all the powers together. We have x, alright, power 8 times, right, we need to add 3n, and divide we need to minus 2n is equals to x to the power of 10. Let us simplify further. We have x to the power of 8 plus n is equals to 8 to the power of 10. So now with this, right, we actually don't need x anymore because they are the same, and they have the same base. Okay, it's both x on both sides. What we can do is we can compare indices. Okay, so comparing indices. Okay, comparing indices, what we have over here is 8 plus n is equals to 10. So 8 plus what is 10? The what is 2. N equals to 2. Okay, so one more time. So over here, right, because the bases are the same, these are both same base. Okay, so because the bases are the same, the powers must be the same as well. So 8 plus n must be equal to 10. Okay, so we can take the index down, 8 plus n equals to 10, then solve for n equals to 2. Okay, so this is the law number 3. Okay, this will be law number 3. And we are going to move on to law number 4 and law number 5. Okay, so with law 4 and law 5, right, okay, I'm going to write a special name for this. Okay, so both these laws, right, are actually our same power law or same indices. Okay, same power law. Okay, same power laws. Okay, so what is going on over here is that when we have a times b as the base multiplied by n, what we have over here will be a to the power of n times b to the power of n. Okay, and the same way also when we have a divided by b as the base and we have the n on the outside, okay, we can split the power n into a power n and b power n. Okay, now so this is actually one way of seeing this from the left to the right. Okay, what we can also do is also to look at from the right to the left. So we also can look it in the other way around, where if the powers are the same, you can combine the bases together, multiply the bases together. Same thing, if the powers are the same in fractions, you can combine the fraction together and leave the power on the outside. Okay, so from the left to the right is to split to the individual powers. From the right to the left, it is to combine the bases together because they have the same power. Okay, so this is law 4, law 5. Let's take a look at y over here. Now, flip to page 57. Investigation. Let us investigate. So first one, 2 to the power of 3 times 7 to the power of 3. So what is this? We have, it will be 2 to the power, 2 times 2 times 2 and times 7 times 7 times 7. Okay, 3 factors over there. Now, because we are doing multiplication, we can rearrange the numbers in our real number system. So we can group them in groups of 2 times 7, 2 times 7, 2 times 7 over here. So we have 3 groups of 2 times 7. So all together we can do is, because we have 3 groups over there, we can simplify it by writing it as an index. So 2 times 7 to the power of 3. So if you want to do it straightforward, you can just do it to 2 times 7 would be 14 to the power of 3. You can do it like this straight away. Okay, now with this, let's take a look at part 2 over here. So we have negative 3 square and negative 4 square. So negative 3 is negative 3 times negative 3. Negative 4 square would be negative 4 times negative 4. 2 factors. And because we're multiplying, we can reshuffle them together, rearrange to one set and second set over here. Okay, one set of negative 3 times negative 4 and the second set as well. So because it's the same set, this and this, so this and this, we can write it as a square, right? Like that. Okay, or if you want, you can just write this as, now because the powers are the same, you can bring the power together and you mash the base together. So negative 3 times negative 4 would be positive 12. So you're going to get 144. Okay, so this is another way of looking at this law. Alright, so in general, when you have your a power n times b power n times and n times, rearrange to n groups of these things. Okay, n groups of these things. So in total, we can say that it's a times b to the power of n, the whole thing power n. Okay, so this is the third law. Let's take a look at some examples over here in practice now 4. Now 3 power 7 times 8 power 7. So what can we do is, because the powers are the same, we can combine the base. So 3 times 8 to the power of 7. So this is 24 to the power of 7. Okay, now over here, 5b power 4, the whole thing cubed. So what we are going to do is, we are going to get 5 cubed b power 4 cubed. So we can split them together. So we're going to get 5 cubed b power 4 cubed is b power 12. Or you can put as b power 4 times 3. So over here, 5 cubed is 5 cubed. Okay, or actually, because we have the thing over there, right, so it's 125, and it will be b to the power of 12. Okay, 125 b to the power of 12. Okay, part C. Okay, part C over there, we have negative 2 c squared d power 5, whole thing raised to the power of 5. So we are going to take out one by one. Okay, so let's take a look at the first one. We have our negative 2, right? We do the negative together. Yeah, so negative 2 raised to the power of 5. We have c squared times 5. We have d power 5 times 5. Of course, you can do the next step straight away, but let's do this together. So we have negative 2 to the power of 5. We have c to the power of 10. We have d to the power of 25. And I think we are satisfied with this answer, unless you are able to answer what is negative 2 to the power of 5. So what is negative to the power of 5? So it's like a turning on and off switch, you know. Okay, so every odd number it will be on, every even number it will be closed. So 1, 2, 3, 4, 5. So there's a negative over there. Okay, so it will have a negative. 2 power 5 will be 32. Then we have c power 10, d power 25. Okay, now let's take a look at part D over here. Part D, we have a lot of things going on, but let us do this one by one. And when you have once again, when you have two things inside the bracket, right, we need to distribute the powers in. So over here we have our h and k, right? So for the first bracket, right, we have our h and k. But I want you to take a look at this, yeah. So we have h power 4, and then we have a square there. So we need to multiply the two in. So 4 times 2 is 8. K square and square will give you K4. Okay. Next, we have our negative 5, H and K. So we have our negative 5, we have our H, we have our K. We distribute the power 3. So we have our cube, K5 and 3. So we have K15, power 15. Okay. Next, let's take a look at the denominator over here. We have 5, we have H, let me split H, we have K. Let's take a look at this. Now 5 cube, H cube and cube again, we have 9, and then K cube in total like this. Alright, so we have this thing going on here. So what are we going to do is we are going to simplify and try to find like group all things together. So first, let me gather all my numbers in front. So all as you can see above, my numbers are negative 5 cube and 5 cube. So let me pull them out in front. So those at the numerator will stay there, so 5 cube, and those at the denominator will stay downstairs, so 5 cube. Alright, then we have our H, right? H. On top we have our 8 and 3. At the bottom we will minus 3. Minus 9. Okay, and K, on top we have K and 15. 4 and 15. At the bottom we have a 3, so we need to minus off a 3, right? So things above will times, things below will minus. Okay, because it's a times above and divide below. So what are we going to do is, as you can see on the left, we have our, okay, we can actually combine this as negative 5 cube as negative 125. 5 cube is also 125, right? And then we have H, 8 plus 3, 11, 11 minus 9 is 2. K, 4 plus 15, 19 minus 3, so K to the power of 16. So negative 125 over 125, we can cancel them out. And this will give us negative 1 of H square K 16, like that. Alright, so this is for part D. Now let's take a look at law 5. Okay, we haven't ended yet, sorry, I'm a bit drowsy, but yes. Okay, for law 5, let's take a look at the next one. Okay, for law 5 over here, instead of times, now we divide. Okay, so over here we can see that 8 power 3 divided by 5 power 3. We can rewrite this as 8 cube over 5 cube, and we can have our, split the cubes up. 8 times 8 times 8 over 5 times 5 times 5, and technically we can also split the fractions out. So we have 3 sets of this fraction. Because they are the same copy, it is just the same as 8 over 5 cubed. Okay, so actually we can do something like this whenever we see the divide sign, and when we see that there's a same power, we can combine the base together. Okay, right, second example, negative 12 and negative 7 both at power 4. So over here we can write as a fraction, split out the numbers, split out the numbers, split out the numbers. We have 4 factors over there, and we can split the fraction to 4 sets of fraction over there. Okay, so over here we have negative 12 over negative 7 to the power of 4, because there are 4 copies of it. So in the same way, okay, a power n times b power n, divide by b power n, you can list it out in a fraction, okay, and you can split the fraction out, okay, n factors. So you have something like this over here. Alright, so before we go on, let us recap a bit. So when we have a and b multiplied together to the power of n, we can distribute the power like that. Okay, and when we have a number divided by another number and both are raised to the power of n, we can distribute the power to the respective numerator denominator. At the same time, if you have a power n, b power n, same power, we can combine the base. So it will be a times b power n. If we have a fraction, a power n and b, or a power n over b power n, okay, we can also take out the n and combine our base, a over b. Okay, both are the same, it's just I just flip here and there, but the direction will tell you whether can you combine or split. Okay, when to use what we judge, but we will see in the next practice now over here. Okay, so over here we are going to do a bit of like mixture between applying law 1 to law 5 of this thing. Alright, so may need to write this in somewhere lah. Okay, so over here we have 221 cubed divided by 7 cubed. So we can combine this as 21 over 7. We can combine the cube. Alright, so 21 over 7 is just 3 cubed. Okay, alright, then we have a to the power of 4, a over 4 to the power of 3. So for this one, what we can do is when we apply, because the 3 is on the outside, the common 3 is outside, we can distribute the power. So we have a cubed and 4 cubed, like that. Okay, so I'm just going to leave it in index notation. Okay, right, so here we have our part C and part D going on here. So let's continue with part C first. Alright, so we have our p square over q cubed divided by p power 5 over q power 7. So before doing anything, we need to settle the brackets by BODMAS, correct? So we have a p square and q. So what I'm going to do is the p and q, something will happen over there. I will need to distribute the 3. So 2 times 3 is 6. At the bottom, 1 times 3 is 3, power 3. Right? Then the next one is I can change the divide into a times. So I think you remember your keep, change and flip KCF. So keep, change your sign, change the operation, and then you can flip your fraction. Right? So over here, what I have is let me just do our law of indices straight away. So on top we have our p power 6. At the bottom we have a p power 5, so I need to minus 5. I have a q to the power of 7 on top. I need to minus 3 from below. So I have p to the power of 1 and q to the power of 4. And we don't need to write power of 1, we just leave it like that. Okay, so p, q to the power of 4. So this is for part C. Part D, alright, part D, last one. So we have our 4x squared over x cubed, the whole thing cubed, divided by 64x to the power of 7 and x to the 21 at the bottom. So before going forward, right, what I want to suggest is this, right? If possible, we try to simplify whatever we can in the respective fractions first, to make life easy, or you can just go ahead and just use what you know about the law of indices. Is entirely up to you. There's many ways to do this. So the first thing that I'm going to do is I'm going to distribute I'm going to simplify what's in the bracket first in each fraction. Then we'll see what's going on. Okay, so over here, right, I have an x squared divided by x cubed. Right, so obviously if I'm going to like cancel this out, I'm going to be left with an x down there. Right, so over here what I have left will be 4 over x whole thing cube. Right, so let me simplify this, whole thing cube, right, and then divided by, okay, let me get rid of this, so x7, x21, so I'm left with an x to the power, okay, x to the power of 21 minus 7 will be 14. Okay, I can do this. Alright, so I will be dividing by 64 to the power of x to the power of 14. Okay, now let me do the cube. Now let me distribute the cube in. So I have a 4 and an x, and to distribute the cube, I have a 4 cube x cube over there. Right? Next I need to, okay, keep, change and flip, KCF. So keep the first one, change the sign, and then flip the fraction over there. So instead of x, right, instead of times, I'm going to put a dot to differentiate easier. Right? X power 14. And then I have a 64 over there. Okay, now next let me regroup so that I align all my numbers and align all my variables together. So I have my 4 cube is 64 divided by 64 on top. My x on top will be power 14, below is 3, so 14 minus 3. So 64 is 64, just nice cancel to be 1. And what my final answer is x to the power of 11. Okay, so that's it for this part D over here. So this is our practice now 5 until here. Okay, so when we come back next time, you will get a chance to see some exercise questions to really assess what's going on over there. Okay, so with this, thank you very much for your attention, and I hope you've been copying the things down well. Okay, that's all. See you.